All right, let's start with solids. So, you know that joke, what would you rather get killed by? A ton of bricks or a ton of feathers? They both weigh a ton and you're dead either way. All right, so the point of that is that it really depends on the density, right? So a ton of bricks still weighs a ton and a ton of feathers still weighs a ton, but would take up a lot more space. Right? So to get an equivalent amount of cork to weigh as much as iron, you're going to have a lot more cork. So the iron nail is heavier per volume. Per volume. Doesn't matter how we measure that volume. We can measure length, width, and height, or we can measure it in milliliters, but per volume, the nail is going to be heavier. All right, so it's the formula for density. It's just the mass per the volume. How do we get the volume? It could be cubic centimeters, where you've measured length, width, and length, width, and height, excuse me. Or it could be in milliliters, where you've submerged something and seen the displacement. Doesn't matter. You have the mass, which you get from a scale, and the volume. Okay. When we go to find the density of a brick, this is why that scene in Indiana Jones drives me a little crazy, where he goes and he takes the gold idol, the head of the gold idol, and he puts some sand on it, and it's about the same size. No stinking way. If you measured the mass of that gold idol head, it would weigh a crap ton. Like, you probably couldn't carry it. So it irked me in the movie, but whatever. So how we do it, we just find the dimensions, length, width, height. You got the mass, and you divide, and you can find the density. We're not going to do this demo with fool's gold, but I left it on here to talk about Archimedes. Archimedes was tasked by the king to figure out if his crown was real or not. And he's the one who came up with the idea of sticking it in water and finding the displacement to see if it was pure gold or if it was gold cut with other things. And the king had, in fact, been ripped off. Okay, so when water freezes into ice, it has expanded. So it expands, right? You know that your pipes burst. Ice floats on a lake. Ice floats in your water. Why is that? Well, it expands. It takes up more volume. The mass doesn't change, but the volume has increased, so the density goes down because you got more volume. All right, and sure enough, ice is actually most dense at about -4 degrees Celsius. Or excuse me, not -4, +4 degrees Celsius. Just very, very cold, but still right before freezing. So at about 4 degrees Celsius, it's the most dense. As you warm it up, it becomes less and less dense, just like a hot air balloon rises and becomes less and less dense. Warm water rises to the surface and becomes less and less dense.